Jai Hind, dear students. Welcome back to your chemistry classes once again. In the previous class, we have discussed about three chemicals which are obtained from sodium chloride, and that is baking soda, washing soda, and bleaching powder. Today's class, we will be discussing about two more of the chemicals, and that is the gypsum and the plaster of Paris. So let's start and continue the chapter acid, bases, and salts. So before we talk about the gypsum and plaster of Paris, let us first of all talk about a topic that is water of crystallization. Although you know few things about this in your previous classes, but we are going to talk about in detail that what is water of crystallization. As in the picture you can see, there is a presence of a crystal which has been shown, and this topic will revolve something around this only. So let's see what is it exactly. Now when we will talk about water of crystallization, we will have certain keywords, that is anhydrous, hydrated, and water of crystallization. These three terms are quite interrelated to each other, and then in the next slide we will try to understand what does these keyword means. So as you all can see, the water of crystallization is the fixed number of water molecules which are present in one formula unit of a solve. Let us take an example which you all know. This is something which you all must have seen in your previous classes while doing the activities and the experiments. Yes, this is copper sulfate. Please correct the spelling here. It is SULPHATE. Now here, when it is blue in color, if you all remember, this is also called as blue vitriol. So the formula of this salt, copper sulfate, is copper sulfate pentahydrate. Why is it called as pentahydrate? Because 5 molecules of water of crystallization is associated here with the given salt. Now when you heat this salt, you will find it will lose its color and will get converted into a white powder, and then it is called as copper sulfate only, and the water molecule will be removed. So when it is containing the water of crystallization, it is called as hydrated salt, and when it is free from that water of crystallization, it will be then called as anhydrous salt. So hydrated means you all know that filled or containing water. So any of the salt when contained with water in the form of water of crystallization will be called as hydrated water, and when it is free from that water of crystallization will be termed as anhydrous salt. So in the next slides we will be talking about certain more examples of the salts which are the hydrated and the anhydrous salts which are very commonly available to us. Now in this slide you can see some compounds have water associated with them. Another example apart from copper sulfate is the cobalt chloride in the crystal form, which is really cobalt chloride hexahydrate. That is 6 water molecule of water of crystallization is associated with it. So that means for each cobalt chloride molecule there are 6 water molecules in the crystal. So when we heat this cobalt chloride crystals which are pink in color, it will remove the water of crystallization, and because of which there will be a loss in the weight and it will turn from pink to blue in color. So these pink crystals are the hydrated salt, whereas once it has been heated then it is turning to blue, and that blue cobalt chloride salt is the anhydrous form of that particular salt. The water that is included in these compounds is called as water of crystallization, and which is the water included in the crystals here. Now in this slide you can see it's given on heating hydrous crystals, that is the hydrated crystals or the salt. When they are heated, they are losing their water of crystallization and they are turning into a powder, and that is the anhydrous salt. They are then said to be anhydrous. So this is represented here with the help of this diagram, and this is one of the practical or activity you all must have been demonstrated in class 7 also, wherein you were told about the process of crystallization. So this crystallization is very much associated with water of crystallization. So as you can see in this picture, the crystals of copper sulfate are heated. The water which is present in the form of water of crystallization, which is associated with each molecule of copper sulfate, will get released, and then the droplets of water can be condensed, and then after it can be collected here. Now the same can be represented in the form of a reaction also, that is the hydrated copper sulfate. When heated, it forms the copper sulfate salt, which is again anhydrous form. Along with that, there are 5 water molecule which goes away and gets disconnected with the hydrated copper sulfate salt. Now this is the due to loss of water of crystallization. If you again take this anhydrous salt and add 5 water molecule, you will find again the hydrated copper sulfate salt can be reformed and it can be regenerated. In this slide you will find there are certain common names, IUPAC name, and the molecular formula of certain salts which are quite common for you all. The very first is the blue vitriol, which you all know, copper sulfate pentahydrate. Second is the magnesium sulfate heptahydrate, because it contains 7 water molecule of crystallization, and it is commonly called as Gypsum salt, about which I have talked previously also. Then after we have calcium sulfate dihydrate, which is called as gypsum, that is CaSO4.2H2O. The next is the green vitriol iron sulfate heptahydrate, because it is containing again 7 water molecule of crystallization. Then after we have the zinc sulfate heptahydrate, which is also called as white vitriol, and the formula is ZnSO4.7H2O. There are more list of certain salts: blue vitriol, glauber salt, that is sodium sulfate decahydrate, which is also called as washing soda. Then after gypsum I have already told you, green vitriol I have already told you, white vitriol again, and the Epsom salt already told. This is more informative. Barium chloride here, no common name, with 2 water molecule of crystallization. Similarly calcium chloride, calcium nitrate, and certain common names are also given here. You can always go through it. And this, just remember few of the ones which you can at least, and the important ones can be like potash alum. It is potassium aluminium sulfate, having the formula K2SO4.Al2SO4 which means there are 24 water molecule of crystallization which is associated with an alum molecule. Now let's see the different properties and the uses of plaster of Paris, which is one of the other chemical here. Now, in general, what is plaster of Paris? It is the basic building material for coating walls and ceilings, and it starts as a dry powder hardened when applied together with water and heat. There are different types of plaster of Paris which is available. The plaster of Paris, the most common one is the gypsum, lime plaster, and the cement plaster. Now let's see what are the different uses and the application along with the preparation. How is it done and how does it look like? This is how the gypsum powder looks like initially. This is something which you all must have seen in your everyday life. Whenever we get a bone crack or there is a problem with our bones, there is a fracture, there is a coating which is applied onto that part of the bone. That material which you can see there is the plaster of Paris, which further gets hardened later on when exposed to air. Similarly, the ceilings can also be made with the help of the plaster of Paris, and the different designs can also be given using that. Okay, so the next slide is showing you the representation. How can we write its chemical formula? It can either be written as 2CaSO4.H2O, or you can write it as CaSO4.half-H2O. As such, there is no concept of presence of half water molecule. So, but we for writing as a whole number, we are taking it as half H2O. So either you write the first representative formula, or you can write the second one. Both will be considered as the correct one. So the chemical name of the compound is calcium sulfate hemihydrate, since it is containing half water molecule of crystallization, and it is called as plaster of Paris because it is obtained from gypsum, which is mainly found in Paris. So that's why its name has been given as plaster of Paris. Now, regarding its preparation, it will be prepared with the help of gypsum. When we are heating gypsum at 100 degrees Celsius or at 373 Kelvin, both are same, you will find it will get dissociated to form plaster of Paris plus 1.5 molecule of water. So either you write it as 3/2 water molecule or you write 1.5 water molecule. Both are similar. So if you just want to double it, you can do that also. So in that case, this will become 1 molecule of water of crystallization and this will become 3 water molecule of crystallization. So the preparation is done in this way by heating gypsum at 100 degree Celsius. This is the part of water of crystallization as discussed in your NCRT. The activity 2.15 is related to this. This is the same diagram what I have shown you previously. So if you take some copper sulfate crystals in a boiling tube, just remember that you cannot use a simple test tube here because you are providing a direct heat here. So boiling tube has a more resistance, has a better quality of glass. So in that case, it will be able to take up the heat in more intensity as in comparison to the test tube. Test tube may break immediately. So here, when you are burning it, when you are giving heat to the copper sulfate crystals, you will find the water molecules will be released and there will be a white colored powder. So it will change its color from blue to white. That means from hydrated salt, it is getting converted into anhydrous salt. This is what has been discussed in the NCRT, that on heating gypsum at 373 Kelvin, it is losing its water molecule and becomes calcium sulfate hemihydrate, and this is called as plaster of Paris here. The same thing I have discussed in the previous slide, the same reaction here I have discussed already. With this, the chapter is getting over in NCRT, and then after we have the question answers, but I'm just going to discuss about gypsum also a bit. These are a few of the uses of the plaster of Paris. You can see it can be used in the following fields as like architecture, art, medicinal or fireproof materials. And the detailing of the same has been done here, how it can be utilized in the architecture, art or the medicinal purpose. Now, gypsum is another mineral here from which we are obtaining the plaster of Paris. Let's see what is it. Introduction is here. Gypsum is a rock-like mineral commonly found in earth's crust, extracted, processed and used by man in construction or decoration in the form of plaster or alabaster. As like plaster, we have another kind of material that is called as alabaster. During the time of Pharaohs, gypsum was used as mortar in the construction of the Cheops pyramid, that was during the 3000 BC. Chemically, if we talk about it, it is calcium sulfate dihydrate, and the impurities which are present in this are the magnesium oxide, aluminium oxide, iron oxide, silicon oxide, calcium carbonate and the magnesium carbonate here. Now the different uses of gypsum, as you can see, it's an abundant mineral, so it can be used in the Egypt ancient sculptures, wall and floor design. Then after gypsum plaster, there are cements, it's one of the abundant mineral, toothpaste also, shampoos as well, and then after agricultural fertilizers, casting molds. There are so many uses of the gypsum and also for the preparation of POP. Other uses, as you can see here, are listed for the different other things. Some can be added to some bread and dough mixes as calcium source and baking aid, but yes, it all depends upon its concentration. How much are we using it? Can be used as a filler and fire retardant in the plastic products. Can be used in the Portland cement and special cement products for set and expansion control. Be a source of calcium and sulfate, sulfur for plant growth. Be used as a modeling material for tooth restorations. be an ingredient in many patching compounds, can be used with glass to fabricate large lightweighted architectural decorations, can be used as a mold materials to fabricate custom body parts for trucks and automobiles, and be an aid in juice extraction of some fruits and the vegetables. These are few of the other uncommon uses of the gypsum. Apart from that, gypsum can also be used, and its product can be used in the home interiors like plaster boards, and the decorative plasters can be prepared with the help of the gypsum here. And this is how we can obtain the gypsum. As like if we are heating the gypsum to obtain plaster of Paris, we can then add water to plaster of Paris to again re-get the gypsum. If you just revert the reaction, you will find that you are able to obtain gypsum from plaster of Paris in a way. This was the revert of the same, that calcium sulfate, heavy hydrate, uh, decahydrate, when that is the gypsum, when was heated at 100 degrees Celsius, was providing the uh, POP molecule as well as the water molecule separately. So this is all about the gypsum, plaster of Paris, and the water of crystallization today. In the next class, we will be discussing about the in-text question as well as the text question. So till then, take care all of you. Thank you.